Okay, quick lesson here, very quick lesson. 7-1 multiplication of properties and exponents. What we're doing today is we're going to deal with exponents a lot. Very first thing they want you to understand is what a monomial is right here, so you can read that. And remember that constants are monomials. The quick answer here is a monomial is any set of numbers and letters, variables that are multiplied together and that have any exponents in them. All are above are not negative, so above 0 or above. In addition to that, you cannot have a variable in the bottom half of a fraction, or otherwise you can't divide by a variable for it to be a monomial. The reason they want you to know monomials is just so that we can then use monomials in understanding how exponents work. So if you go ahead and read this and understand that section of what is and what isn't a monomial, then you can go ahead and try that. When you get to the guided practice, I'll give you the help. This is not, this one is, and this one is not. If you don't understand why they are not, then come ask me. And finally, not finally, but before we get into the actual lessons, we got to remember what a exponent is. That is a base raised to an exponent power. In this case, our base is 3, and our exponent is the 4. So in here, b equals 3, and e equals 4. Okay, so that's your base and your exponent. So when you multiply or deal with exponents today, you make sure that the base is the same. All right, so now here's the key concept that I want to talk about first, and that is the power, the product of powers, the product being multiplying two numbers, the answer when you do a multiplication, and what happens when you do a multiplication and both those numbers have powers to them. For example, I have a to the m raised to a to the n. That says p, doesn't it? So a to the m plus or times a to the p, you just add the exponents. Right there, you add the exponents. So it's still the same base, but you just add the exponents together. What is that example? We got b here multiplied, b to the third multiplied by b to the fifth. I just add the exponents and get b to the eighth. Here's the second example, g to the fourth times g to the sixth. I add the exponents and get g to the 10th. I'll let you go ahead and look at that part. If you understand that part, try the guided practices. The guided practices on, this is what, page 292. The guided practice answers here are, let's see, 2a is 21y to the third, and 2b is 24. I don't have my glasses on, I'm having to squint. 24r to the sixth, and then x to the fourth, and then t to the fourth, I think. Okay, the numbers are small, I'm having a hard time reading them, but there you are. So if you get those two, when you try those two, that's good. The next key concept is that right there. It's called the power of a power. So what happens when I have a base, an exponent, raised to another exponent? So a power of something that already has a power on it. And this is the example right here. If I have a to the m raised, all raised to the p power, I now multiply those exponents, keep the same base. A is my base, but I can just multiply the exponents. So b to the third raised to the fifth is b to the 3 times 5, or b to the 15th. Same over here with the second example, g to the 6 times 7. I multiply the two, 6 times 7, and I get g to the 42nd. And I'll let you go ahead through this. Oh, got to turn the pen on each page. I'll let you go ahead and go through that. And if you want to simplify this guy right here, that guy's answer is H. Right there. So if you don't get H when you try it, then come see me and see why you didn't get H. Now the third and final part of this lesson is what's called a power of a product. So we had product of a power, we had power of a power. Now we're going to reverse that first one. Instead of product of a power, we're going to have power of a product. So power of a product means you have two variables inside your parentheses, all being raised to one exponent on the outside. So A and B are our two variables on the inside of our parentheses, and M is our exponent. What you can do is you can rewrite that as each individual part of the inside the parentheses, each individual variable, and raise each one of them to the power on the outside. So that's what that is. So something like this becomes a rather complex statement, and remember that anything, including constants, are raised to the fifth power. Okay, so when that constant gets raised to the fifth power, you get negative 32. Okay, and x to the 1 raised to the fifth power stays as x to the 1, but y to the third gets as a power of a power, so y to the third raised to the fifth is 3 times 5, or y to the 15th. Okay? In this example, once again, if you look at it and want to mess with it, it's basically just a area of a circle problem where you get to have a power of a power. You get to do a very simple example, much like this one up here. These two become the same kind of process. Then the guided examples for A, if you get it, A is 9 and x squared y to the fourth, and B is 10 A squared B squared. So this is A and this is B. All right. Then the last example here, I said there was one more. When you simplify monomial expressions, I thought I was on the last one last time, but this is the last key concept. Now, but it's not really a rule associated with exponents. We had the three rules. Now here's the rules when you're asked to simplify. The things have to happen. Each variable base appears exactly once. So I can't have b squared times a squared times b squared again. I would have to combine the two bases, b squared. Okay? There are no powers of powers, so I can't have a squared raised to the second power times b squared, because the a squared raised to the second power is a power of a power, so I have to get rid of that. And all fractions must be in simplest form. So if I have some kind of fraction, let's say 1/2 raised to the second power, I would have to change that to 1/2 times 1/2, which gives me 1/4. So it has to be simplified. And all numbers should be taken all the way to the end. So in that example, I shouldn't leave a 4 squared. That should be 16. And I also shouldn't leave 1/3 squared, as that should be written as 1 to the 9th. Okay? Or 1/9, sorry. Okay, so having done that, if you try that and see what you get, that'll be good. And let's take a look at this. Look at this and see what they've done there. They've just tried to tell you each step as they go. So kind of follow that through and see if you can do those steps, if they make sense to you. And then do this item right here, this guided practice number 5. Your final answer should be 32, a to the 5th, and b to the 10th. And I think that's a to the 6th. Yeah, that's a to the 6th. Okay, b to the 10th. If you don't get that, come see me and we'll go through it. By the way, when I went through it the first time, I thought I was going to get the wrong answer, but you end up with a big number over here for your number, but you forget, I forgot that this number is a little number or a little fraction, and when you multiply the fraction times the -4 times the -4 raised to all the powers, it has to go. You do end up with 32. Okay. So now what is your assignment? Your assignment will basically be, let me see my notes here. 29, is that 29? 21, excuse me, can't read my own writing. 21 through 63, every third, and then number, and now I've lost track of what my last number was, number 64. Okay, so that's the whole problem. That should be 15 problems. So there you are. Good luck.